about the round off value and the significant numbers. Okay. So now you will see that. So you can take the brick and the mass. Yeah, these two things are going to explain the significant numbers and round off. Now you can see that this is one brick. That brick has the length, breadth, and height. See that length. The length is 15.4 or 5. It is between that 15.4 and 5. It's not an exact value. So we can write 15.45 centimeter. So it's not an exact value. It is not measured in the scale exactly 15.45. Roughly we are taking that value 15.45 centimeter. So 15.45 centimeter. Right? So this is the length of the brick. So here that 15 and 4 is a certain. It is not going to change. But we have a doubt on that last digit 5. That's called uncertain. Because it may be a 4 or a 6. So we are roughly taking that reading. That's why we call it as there is an uncertain value 5. Okay. So it may be a 4 or 6. We don't know that. So we are taking that into 5. So suppose we are rounding off this value. The final value, the certain value only changes. The remaining 3 values does not change. That is called certain value. The value which is changes is called uncertain value. Right? Okay. So this called these values are called significant figures. So now we are going to see the significant figures, rules of significant figures. So what are the rules? First rule. In any measurement, all non-zero digits are significant. So all the non-zero digits, that means 1 to 9, all the numbers are significant. Now you can see that we are measuring that rod. The weight is 62.45 kilogram. So it is shown that meter 62.45 kilogram. That is the weight of the rod. So here that mass of the rod is 62.45. So here all the numbers are non-zero digit, non-zero numbers. So the significant numbers are 4. So second rule, in any measurement, all digits including zeros are significant for a decimal number that is greater than 1. So here the digit also, the zero numbers also we are going to take taken as a 0, but it should be with it between the non-zero numbers or with the decimal numbers. See here that length of the rod 6.407. Here 0 we have to consider 0 is a significant because 0 is between the non-zeros. So it is definitely it is greater than 1. So here the significant numbers are 4, 6.407. So 0 is also a significant. Third rule, if the decimal lies between the zeros and 1, the zeros right to the decimal point, but left to the first non-zero digit and non-significant figures. So here we are going to take the decimal numbers, right side and left side of the decimal number. In that decimal number, right side, we have the value of right side. You can consider that number 0.00645. So the right side, left side is less than 1. The right side is 0 number, it's not significant, but non-zero is trailing the after the zeros. 6, 4, 5, 2 are significant. But the 2 zeros are not significant because the left side of the decimal point is 0. Suppose it is 1, you can consider that these 2 zeros are significant. Now these 4 numbers 6, 4, 5, 2 are the significant numbers. The 2 zeros are not significant. Suppose 1 is on the left side, you can consider that the other 2 0 also. Now rule number 4, if the measurement is a whole number, then the case becomes ambiguous. If there are zeros to the left on an understood decimal point, but to the right side of the non-zero digit. To remove this ambiguity, the number should be reported in scientific notation. Suppose you are writing in a very big number, that number you have to simplify by using that power values, by writing the power values. So the scientific notation must be used. So see here now, you can take a number, very big number 2507220. It's a very big number. So instead of writing like this, you can write 2.507 into 10 to the power of 3. So you can raise the power values and you can simplify that this value. Here the significant numbers are 4. Okay, if there is no decimal point, suppose decimal point is there, we have to consider the 3 zeros. but there is no decimal point. So only these 4 numbers are significant. So we can write 2.507 into 10 to the power of 3. So that's why in these 3 zeros are writing the power values of 3. So you can write 2.507 into 10 to the power of 6. So 3 zeros and 507 also we have other side of the decimal point. That's why we are writing 10 to the power of 6. So here significant numbers are 4. Okay, this is the fourth rule of the significant numbers. Next, fifth rule. All the final zeros in a decimal number obtained by a rounding of a decimal to a given number of decimal places are significant. So all the final zeros in a decimal number obtained by a rounding off. So see that now we are going to take a number, one decimal number, 9.8982 is the decimal. So it has the decimal number. After that, the total significant numbers are 5. So we have to rounding off the rounding of this value. Because we can rounding off this value for 2 or 3. Suppose you are rounding off that value up to 2 decimal. So you can write 9.90. So 8 is here. So 8 is greater than 5. So we can write that 9.90. This value is greater than 1. So that 90 is trailing the decimal point. So we have to consider that 0 is also a significant. Because it is right side of the decimal point and left side of the decimal point is greater than 1. So total decimal number significant numbers are 3. Rounding off the given numbers to the required significant figures. So how to rounding off the value? It has a certain rule. So now we are going to see the rounding off the given numbers. Then how to require the rounding off the values. The preceding digit is raised by 1. If the significant digit to be dropped is more than 5. And it is unchanged if that latter is less than 5. So already you know that suppose the value is greater than 5, you can add that one value, or less than 5, you can deduct 1. So round off that value 8.917 in 3 significant. So 3 significant means 8.9, 1 and 7 is there. Here you can see that significant numbers are 4, but we have to reduce that into 3 significant numbers. So 8.91. Here the 7 is greater than 5. So you have to add that 1 with 92. So 8.92. So we round off that value. Let us consider another one example. 7.9342. Okay. So this number, you are rounding up this value up to 3 digit. See the final number is 2 and fourth significant number is 4. Suppose we are rounding up this value. That final number is 2. It is less than 5. So you can round off this value 7.934. Okay, we leave it that is a very small compared to the 5. It's not a 5 greater than 5. Suppose that you can see that another one, it is exactly 5. Then how we have to round off these two values? 3.945. So before that 5 it has a 5 it has a 4. And another one value before 5 it has a 7. Suppose it's an odd number or even number. So it is an even number means you should not change that value. So 3.945 is that 5 is the greater value. Before that 5 you have a value of 4. So it is an even number. So suppose that value is 5 or less than 5. Less than 5 means we will leave it there. Suppose it is 5. For even number you should not change that value. So you can take that round off value of 3.94. Here it is a 7. It is a odd number. Odd number means we have to increase that one value. So we can write 3.94 and 3.98. So it's a even number means you should not change anything. Suppose it's an odd number, you have to add 1. So this is a one rectangular area. So now we are going to add that value and we are adding the error. That is error. Already you know that Z and AB. Using that we have calculated the value. So using that formula, now we are going to do the calculation. That length is given there and breadth is 5.1 plus or minus 0.1. Plus or minus means that value is plus 0.51 or less than 0.51. So you are add or subtract. It is that value is between the two values. That's why we are writing like this. So area of that closed area. So area equal to L into B, that is length into breadth. So multiply that, you will get this value. So this value also you have that error of plus or minus 3.2 or plus or minus 1.3 meter square. So when you are multiplying the two value also, it has the error. You have to write plus or minus 1 meter. See A equal to 41 plus or minus 1. We are rounding up that value. So uncertainty is the 1 meter square. That 1 meter square is not a certain value, it's an uncertain value. That means it will change. So number of significant digits are 2. Okay, significant numbers are 2. The relative error of the value of number specified to significant figures depends not only on n but also on the number itself. So it is depending on the number also, not only the significant figures. Right? So for example, for that, the relative error. So M1 equal to, you can take 10.01 meter and M2 equal to 8.5 meter. So now you are going to, that error is 0.1 meter. So 0.1. So it is, they are less than or greater than the 0.1 value. So it's called percentage error. You know that. So when you put into 100, it's called percentage error. That is plus or minus 1%. Or M2 equal to 0.12 percentage. So this is also called as percentage error. Intermediate results in a multiple step calculation should be taken to a additional significant figure in every measurement that the number of digits in the least precise measurement. So intermediate results, that is, there is a plus or minus between that one value, it has one value. So now we are going to see that. Let's see that 6.55 number of digits are 3. That is 1 by 6.55. You are dividing that value, definitely you will get that 0. 0.00 and you will get the something value, that is 0.152. Here also the decimal number is 3. You are not considering that 0. So when you are writing that 1 by 0.152, it is 0.658 n equal to 3. So in this method is not correct because already you are rounding up that value. So now you can see that how to do the calculation. See that 1 by 6.55. You should not round off that value, first value. Suppose you are doing like that, it will change. So the digit is 4, 1.527. Then 1.527, you are doing this calculation, you will get the correct answer is 6.55. So you will get the exact answer. So suppose you are keeping that one decimal number, you will do a mistake. So you can't get